Hi guys, and welcome back for lesson 10.4. All right. My answer key to my notes will be on Google Classroom for you. Just a quick note about the notes. I'm going to go through the terminology, the new vocabulary. I'm going to go through 4 theorems. Then I'm going to go through some example problems. If you feel like you understand the material after we go through the vocabulary and the theorems, you may not need to watch all the example problems. Feel free to jump over and try the textbook problems on your own. If you get stuck, maybe come back to the video and look at the example problems. All right, so that's just a suggestion. So as I said, my answer key will be on Google Classroom for you, and we're going to get started with the vocabulary, which I already wrote up here for us. So the first term is inscribed angle. Okay, an inscribed angle is an angle whose vertex is on the circle and whose sides contain a chord of the circle. All right, so what would that look like? Well, here if I have a circle, and if I have an angle whose vertex is on the circle. So an angle that might look something like this. Okay, the vertex of that angle is there. Here's the angle I'm referring to. That angle right there is called an inscribed angle because its vertex is on the circle and its sides, here's one side, here's the other, contain chords of the circle. Okay, and we're going to talk about what the measure of that angle is when we get to the theorem part. Okay, the next term, we're actually going to use the same diagram. The next term is, get a different marker, intercepted arc, an arc that lies between 2 lines, rays, or segments. So when we look at this inscribed angle, I'm going to often say to you, what arc does it intercept? What arc sits inside of the angle? Okay, that arc is contained, it's between two lines, okay, rays or segments. So this arc right here, that would be your intercepted arc. Okay. Next we have subtend. This is just a term that you'll see in this textbook and probably in some of the homeworks. If the endpoint of a chord or arc lie on the side of an inscribed angle, the chord or arc is said to subtend the angle. Okay. Moving on, we have an inscribed polygon, a polygon in which all the vertices lie on the circle. Okay, so if I was to draw a circle, and then let's say we have a polygon whose vertices are all on the circle. So we have a pentagon. All right, vertice on the circle, on the circle, on the circle, on the circle, and on the circle. So we would say that that is an inscribed pentagon, an inscribed polygon, because it's a polygon whose vertices lie on the circle. All right, the next term, we're going to actually go and look at the same diagram. A circumscribed circle. Okay, so a circle that contains all the vertices of an inscribed polygon. So this polygon is inscribed in the circle. The circle is circumscribed about the polygon. All right, just 2 different terms looking at the same diagram. All right, so that is it for vocabulary. I'm going to erase the board and get set up to go through the 4 theorems with you. All right. Okay, the first theorem is the measure of an inscribed angle theorem. All right, so we talked about an inscribed angle, which again, an inscribed angle is an angle whose vertex is on the circle. So something like this. Okay, there's my inscribed angle. And this theorem tells us that this angle measure is equal to half of its arc. Okay, so I'm going to label it. I should have done this at the beginning. Let me label my angle A, trying to copy my notes, D, B, the center of the circle is C. Okay, so the inscribed angle theorem tells us that the measure of angle ADB is equal to 1/2 the arc that it intersects. Well, that intercepted arc is this arc right here. Okay, arc AB. So the measurement of angle ADB is equal to 1/2 arc AB. All right, so just as an example, if I said that the arc was 100 degrees, then the angle would be 50 degrees. Okay, now sometimes the angle will be given and you double it to get the arc. Other times the arc will be given, you take half of it to get the angle. We're going to look at some examples in just a minute. Okay, so that's the first theorem for today. The next theorem, erase the board. The next theorem is the inscribed angles of a circle theorem. Which says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, so the diagram would look something like this. All right, I know it looks a little crazy right now, but let's break it down. All right, if I look at this angle first, and maybe I'll actually highlight the sides of that angle in red. Okay, if I asked you to identify the arc that it intersects, highlight, look for the arc that it intersects. Well, the arc that sits in between the red angle is this arc here. Okay. And then if I trace over, highlight my blue angle, so just kind of making my eyes focus, this angle right here. Okay. What arc does that blue angle intercept? All right, what arc lies in between? It's the same arc, right? So, going back to the theorem we just spoke about, if the angle is 40 degrees, what's the measure of this arc? It should be double. It should be 80 degrees. Okay, if this arc is 80 degrees, what's the measure of this angle? 40 degrees. So this theorem is just illustrating that if you have two inscribed angles that intercept the same arc, then those two angles have to be congruent to each other. Okay. All right, the next theorem is the inscribed right triangle theorem. Right triangle theorem. All right, which says this. If a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. Conversely, if one side of an inscribed triangle is a diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is the right angle. All right, so it's very wordy, but let's take a look and see if it makes sense to us. I won't extend it. Okay. So if you look at this angle right here, which I'm going to redraw in red, this angle right there, I'm going to start asking you guys quite often, what kind of angle is it based on the location of the vertex? Okay, because remember, we talked about central angles, angles whose vertex is on the center of the circle. Now we have inscribed angles, the vertex is on the circle. So this angle is inscribed. And we just discussed earlier that this angle is equal to 1/2 the arc that it intercepts. Well, which arc does it intercept? Use a marker that actually shows up. Here we go. Which arc does this angle intercept? Well, if I was to, maybe actually, let me extend the sides. It's a little visually easier to see. Extend the side. Extend the side. What arc sits inside of that red angle? This arc sits inside of the red angle. What kind of arc is that? It's a semicircle, right? It's half the circle. If this arc is 180 degrees, right here is my diameter. It's how I knew it was a half a circle. If this arc is 180, what's the measure of this angle? It's a 90-degree angle. Okay? So we just basically showed what this theorem is saying. This theorem is saying that if you have a right triangle, okay, then the hypotenuse is the diameter of the circle, which it is, right? Or it's also saying that if you have one side of the triangle its side is the diameter, then you have a right angle. You have a right triangle. Okay? So that illustrates that theorem. And the last theorem for today, and this is an important one. The other two that I just showed you, not that they're not important, but you can still figure out all of the answers by just using the inscribed angle theorem. But this theorem definitely will be helpful when doing certain problems. And it's the inscribed angles. Oh, nope, that's not the right one. Inscribed quadrilateral theorem is what I'm supposed to be doing. Sorry. I was going back up to the beginning. Inscribed quad theorem. Okay, so we're going to look at an inscribed quadrilateral. So remember, that means we have a circle, and then we have a quadrilateral four-sided figure whose vertices are all on the circle. And I think they name it, yep, they name the circle C, and in the notes it's E, F, G, D. Okay. So we have this inscribed quadrilateral. And the theorem says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Okay, so this is going to be really helpful for a lot of problems that we're going to see. Opposite angles, meaning angle D and angle F, are supplementary. So the measure of angle D plus the measure of angle F equals 180. And then opposite angles E and G are also supplementary. So the measure of angle E plus the measure of angle G equals 180. Okay, and then we also already know from previous chapters the four angles of a quad all add up to 360 degrees. Okay, so that is all the information. Now I am going to work through a few example problems. All right, so if you flip to the next page with me. All right. So we have this diagram, circle, they call it N, and then we have C, B, I think that was given. Yeah. Sorry guys, I'm trying to see if this was given or if I added this in. I need to B and into C. All right, you have 7.3 to 3.9. Okay. And I think that was all that was given. Oh, 28 degrees. 28 degrees. Okay. So what I often suggest in this chapter is don't even read what the questions are asking. It's usually best to look at the diagram and mark as much information as you can before you start trying to answer the questions. Because sometimes if you start trying to answer the questions, you're going to get stuck. You're going to be like, I don't know how to figure that out. But if you look at the diagram and mark up everything you possibly can, going through and answering the questions, you'll fly through them. Okay, so I'm going to look at the diagram and try to figure out what do I know. Okay, what information can I determine from here? Well, I see an inscribed angle, an angle whose vertex is on the center. So if I extend the sides, this arc sits inside of that angle, right? So if I extend the sides of this angle, arc AC is the intercepted arc. Well, if that's the intercepted arc, then the arc, okay, is double the angle. All right, so 28 times 2 will give you the 56 degrees. All right. A few other things that I notice. I see a diameter. That's the diameter of the circle. So if that's the diameter, that means from B all the way around to C, that's 180 degrees. And then from C all the way around to this B is also 180. So that's going to allow me to figure out arc AB. Because if this whole arc is 180, I just do 180 minus the 56 to get 124. 124 degrees for this arc. Okay? So I know all my arc measurements. All right, from there, what are some other pieces of information that we can determine? Oh, if this is a diameter, right, and this is an inscribed angle, what's the measure of this angle? We just talked about this in one of the theorems. It's a right angle, okay? Or extend the sides of that angle. It intercepts the semicircle, 180. So 180 divided by 2 is 90. That's a 90-degree angle. All right. I could also look at the triangle. I could find this missing angle measurement. Or I could look at the inscribed angle and take half of this arc to get the angle measurement. Either way, the three angles add up to 180, or it's an inscribed angle, extend the sides, it intercepts arc BA, so it's half of 124, which is 62. All right. Last thing I think I can figure out, because this is a right triangle, I could use Pythagorean theorem to solve for the hypotenuse. So I'm going to do that off to the side here. So I have a squared plus b squared equals c squared. 7.3 and 3.9. 7.3 squared plus 3.9 squared is equal to c squared. All right. So you're going to have 68.5 when you square and add is equal to c squared. So the length of BC is approximately, you would take the square root of both sides, is approximately 8.276. 8.276. Okay, that's this length here. 8.276. Okay, so now that I have everything marked up, answering the questions is going to be easy. The first question says, what is the measurement of angle A? Well, now I know it's 90. Question 2 says, what's the measurement of angle C? 62 degrees. What's the measure of arc BC? Or no, it doesn't say arc BC. I'm sorry, I'm not reading the question correctly, right? Number 3, what's the length of BC? Well, the length of BC is approximately 8.276. What's the measure of arc AC is the next question, 56. And finally, what's the measure of arc AB, A to B, minor arc, 124. Okay. So again, marking up the diagram is going to help you answer all the questions more easily. All right. And I'm going to do problem number 7 as the last one for today. So problem 7, this one will be hopefully faster than the last. I have a quad A, D, B, C. All right. And you're given N, M, 165. Now this is where that last theorem is going to be very helpful. What do we know about opposite angles of an inscribed polygon, of an inscribed quadrilateral, excuse me? The opposite angles of an inscribed quad are supplementary. So that means that M plus 65 are equal to 180 and N plus 100 are equal to 180. Okay, so 2 simple one-step equations to solve. You're going to get M is 115, right? Subtract 65 from both sides. And then you'll get N, subtract 100 from both sides, is 80. Okay. These are also inscribed angles, so keep that in mind. If I wanted to, all right, here's 100 degrees, extend the sides, I know that this arc, this whole thing, is 200 degrees. Now, I don't know yet. I could probably do some more work and figure it out. I don't know that what BC is or CA. The whole thing is 200, but that doesn't necessarily mean it's 100, 100. Okay, so be careful about that. All right, or I could go to the 80-degree angle. If I extend the sides, okay, here's one side, here's the other, so it intercepts this arc. So I know from here all the way around to here, 80 times 2 is 160. Okay, and I can keep going. All right, 65, double it, and you'll know the measurement of arc DAB all the way around. Okay, so keep in mind those inscribed angles. All right, that's it for today. See you guys later. Bye.